Welcome to episode 3 of our AI series here at SaaS Startup Academy. In this episode, we're tackling a highly important and timely topic: AI bias and fairness. As AI systems increasingly influence decisions that impact our lives, from job recruitment to lending and even criminal justice, it's essential to understand how bias can creep into these systems and how we can strive to make AI fairer. Today, we'll break down what bias in AI is, examine the different types of bias, data bias, algorithmic bias, and user bias, and walk through some real-world examples of AI bias that illustrate how these systems can both help and harm society. By the end of this episode, you'll have a solid understanding of AI bias and some strategies to mitigate it, making AI systems fairer for everyone. If you're ready, let's dive in. Understanding bias in AI algorithms. To understand AI bias, we first need to understand what bias is in the context of artificial intelligence. In everyday life, bias means a tendency to favor one thing over another unfairly. Similarly, AI bias refers to the prejudices or systematic errors in AI algorithms that cause them to produce skewed results. These biases often stem from the data the algorithms are trained on, the methods used to build them, or even how users interact with the systems. AI systems are designed to find patterns in vast datasets and make decisions based on those patterns. When the data used to train these systems is not fully representative or contains underlying biases, the AI system inherits and amplifies those biases, leading to unfair or discriminatory outcomes. Bias can impact AI systems in ways that may seem small but can have far-reaching consequences when applied to critical decisions in healthcare, hiring, criminal justice, and more. One of the most famous instances of AI bias occurred when facial recognition systems used by law enforcement were found to have much higher error rates for identifying people of color, particularly black individuals. The AI models had been trained on predominantly lighter-skinned faces, leading to these higher error rates. This is just one of many examples where bias in AI can affect people's lives in significant and sometimes harmful ways. The key to tackling AI bias is to understand where it originates and how it manifests, which brings us to the various types of bias in AI. Types of bias: data bias, algorithmic bias, and user bias. Bias in AI doesn't come from just one source. It can emerge at different stages of the development and deployment of AI systems. Here, we'll explore three major types of bias: data bias, algorithmic bias, and user bias. Data bias. Data bias occurs when the data used to train an AI system is incomplete, unrepresentative, or skewed in some way. This can happen when certain groups are overrepresented or underrepresented in the dataset. For example, if a facial recognition system is trained on a dataset that consists mostly of images of white men, it will likely perform better at recognizing white men compared to women or people of color. Data bias can also come from historical inequalities. Consider the case of predictive policing algorithms, which are designed to help police identify areas where crime is likely to occur. If the training data for these algorithms is based on historical crime data, it may reflect a disproportionate number of arrests in minority neighborhoods due to existing biases in policing. As a result, the algorithm may direct more police resources to those areas, further entrenching the bias. Another classic example of data bias is in the job recruitment sector. AI systems that screen resumes may inherit biases from historical hiring practices. If a company's past hiring favored certain demographics, the AI might replicate those preferences, filtering out equally qualified candidates who don't fit the historical mold. Addressing data bias involves collecting more diverse and representative datasets, but it's easier said than done. Often, data collection practices reinforce existing social biases, and addressing this problem requires both technical solutions and broader societal efforts to ensure more fairness in the data itself. Algorithmic bias. Algorithmic bias is introduced by the design of the AI algorithms themselves. Even if the data is perfectly unbiased, the way an algorithm processes that data can still lead to biased outcomes. This occurs when an algorithm is designed in a way that unintentionally favors certain groups over others. For example, machine learning models often rely on simplifying assumptions to make sense of complex data. These assumptions may ignore nuances that are important for fairness. A simple algorithm that predicts loan defaults based on income, for example, may fail to account for systemic barriers that affect different groups' access to wealth, leading to discriminatory results. Another way algorithmic bias can arise is through hyper-optimization for certain metrics. Algorithms are often built to maximize accuracy, speed, or efficiency, but these metrics don't always align with fairness. In some cases, an algorithm may perform very well overall but still treat certain minority groups unfairly. To combat algorithmic bias, developers need to build fairness into their models from the outset. This can involve testing for bias during development, adjusting algorithms to correct for known biases, and ensuring that the performance of AI models is equitable across different demographic groups. User bias refers to the biases introduced by the people interacting with AI systems. Even the most carefully designed and trained AI systems can be affected by the behavior and biases of the users who operate them. This can happen in several ways. Biased feedback loops. When users provide feedback to AI systems, they can inadvertently reinforce bias. For example, if a recommendation system suggests content based on user preferences, and users predominantly engage with biased content, the AI may continue to serve up more of the same biased content, creating a feedback loop that perpetuates discrimination. Misuse of AI. Users may intentionally or unintentionally misuse AI systems, leading to biased outcomes. For instance, an HR manager might misuse a hiring algorithm by giving it biased inputs, such as always prioritizing resumes from certain schools or companies, which skews the algorithm's recommendations. Interpretation bias. Users may interpret the results of AI systems through their own biases. For example, a doctor using an AI tool to recommend treatments may unconsciously favor AI suggestions that align with their personal experiences or prejudices, even if those suggestions aren't the best option for all patients. To address user bias, it's important to educate users about the limitations and potential biases of AI systems. Transparency is key. Users should understand how AI systems work, what data they're based on, and what risks of bias exist. This helps prevent misinterpretation or over-reliance on AI tools. Real-world examples of AI bias. Let's look at a few real-world examples of AI bias to better understand its impact. 1. Gender bias in recruitment tools. One of the most famous cases of AI bias occurred at a major tech company that developed an AI-based hiring tool to screen resumes. The algorithm was trained on resumes submitted over a 10-year period, but because the tech industry is male-dominated, the resumes from this period skewed heavily toward male candidates. The AI picked up on patterns that favored male applicants and penalized resumes that mentioned female-oriented terms, such as women's chess club. As a result, the algorithm systematically favored male candidates over female candidates. This example highlights how historical biases in data can perpetuate inequality and discrimination in AI systems. The company eventually scrapped the tool, but it serves as a cautionary tale about the risks of relying on biased data to train AI. 2. Racial bias in facial recognition systems. Facial recognition technology has made headlines for its problematic accuracy rates, particularly when it comes to identifying people of color. Studies have shown that facial recognition algorithms are significantly less accurate at identifying Black and Asian faces compared to white faces. One high-profile incident involved the wrongful arrest of a Black man in Detroit after a facial recognition system misidentified him as a suspect in a crime. This error occurred because the system had a higher error rate for darker-skinned individuals, leading to a false match and a major injustice. Facial recognition technologies are now under intense scrutiny, with some cities and states opting to ban their use by law enforcement due to concerns over racial bias and privacy violations. 3. Bias in predictive policing algorithms. Predictive policing algorithms are designed to help law enforcement agencies allocate resources by predicting where crimes are most likely to occur. However, these algorithms are often based on biased crime data, which can result in a disproportionate focus on minority neighborhoods. The algorithms essentially reinforce existing biases in the criminal justice system by directing more police presence to communities that have historically been over-policed. One example of this occurred in Chicago, where a predictive policing algorithm was used to identify individuals deemed likely to commit violent crimes. The algorithm disproportionately targeted Black and Latino residents, leading to heightened surveillance and increased arrests in minority communities. 4. AI bias in healthcare. AI systems are increasingly being used in healthcare to assist with diagnostics and treatment recommendations. However, there have been instances where AI systems have demonstrated racial and gender biases, leading to unequal treatment outcomes. For example, An AI system used to recommend treatments for heart disease was found to be less accurate in diagnosing heart conditions in women compared to men. This bias occurred because the algorithm had been trained primarily on data from male patients, leading to poorer outcomes for female patients who were not well represented in the training data. Conclusion: tackling AI bias and building fair AI systems. AI bias is a complex and multifaceted problem, but it's one that we can address through a combination of technical solutions, better data practices, and human oversight. As we continue to develop AI technologies, we must remain vigilant about the risks of bias and strive to build systems that promote fairness and equity. In this episode, we've explored what AI bias is, examined the different types of bias, and looked at real-world examples where AI bias has had tangible impacts on people's lives. By understanding the sources of bias, whether from data, algorithms, or users, we can begin to tackle these issues and create AI systems that work for everyone. If you found this episode insightful, be sure to hit that like button, subscribe, and turn on notifications so you don't miss any of our upcoming episodes. We'll continue to explore the world of AI and technology, diving deeper into topics that matter. Stay tuned for episode 4, where we'll explore how AI is transforming industries and shaping the future of work.